All right, kids, it is the last week of April, and this week we are going to be reviewing everything that we've done with quadratics so far. Some of that is stuff that we've done over the last week or so, completing the square, finding the discriminant, but some of it is from way back in the beginning of March before we even left for remote learning, when we were solving equations using square roots, using zero product property, using quadratic formula. And we really need to be good at that. This is something that you're going to see again next year in geometry and also in Algebra 2. And we never really got a chance to wrap that up before we left in the middle of March. So we're going to spend some time with that this week, kind of what I call the quadratic solving unit. And then the following week, the first week in May, we're going to start our quadratic graphing unit. So this is just quadratics galore. So what we've done here, we've done before, but we got to be good at it, all right? And here, you're asked to solve the following without using the quadratic formula. Remember, quadratic formula, you could use that to solve all quadratics. It's just that it's very long-winded and takes a lot of time, and I want you to be able to recognize when you don't have to use quadratic formula. And look at this first problem here. We started talking about this stuff last week on Thursday. If you look at this first problem here, there is no b term. There's just an x squared term and a constant. Remember, when we just have the x squared term, we just want to get the x squared by itself. So we divide both sides by 2. We get x squared equals 18. Now remember, we're not done. We have to take the square root of both sides. Now the square root of 18 is not going to be a nice number. We'll punch that into our calculator. It comes out to 4.24 if we round to the nearest hundredth. But remember, whenever you do that, you have to give the plus or minus. It's actually positive 4.24 or negative 4.24. Okay? Remember, when we're solving, what we just found here is also called the x-intercept. It's also called the solutions. It's called the zeros. There's even a third word for it. So this is old stuff. So if there's the bottom line, if there's no b term, you just want to get x squared by itself and take the square root in the end. So here in this one, I'm going to move this over. I get 4x squared equals negative 4. I divide by 4. I get x squared equals negative 1. But remember, we now take the square root of both sides, but we can't take the square root of a negative number. So this one would be no solution. All right. Down here, same thing. There's no b term. If there's no b term, we want to get x squared by itself. Don't go to your calculator right away. You should recognize that both of these are perfect squares. So now when we take the square root of both sides, we simply get 7 over 5 equals x. But remember, it is still positive or negative. All right. Let's come back to number 4 in just a moment. Number 5, okay. Again, there's no b term. You want to get x squared by itself. Move that over by adding. You end up getting 0 equals 5x squared. You divide by 5. And obviously the square root of 0 is simply 0. Same thing on number 6, folks. There is no b term. So the bottom, I need you to remember, if there's no b term, you can solve using the square root method. So you want to move this over by subtracting. So that's going to turn this into a 50. Now to get rid of the 1/3, you guys know you need to multiply by 3. So you get x squared equals 150. Now when you try to take the square root of that, that's not going to be a nice perfect square either. So we can go to our calculator, we get a decimal. and we get 12.25 rounded. But remember, that is plus or minus, okay? So, no b term, go ahead and isolate x squared and take the square root in the end. This one, there's only one problem on the sheet like this, but we did spend some time with this during remote learning. This is called solving a square root equation. We want to get the square root thing by itself. So we would move this 5 over by subtracting, turns it into 18. Get rid of this 3 by dividing both sides, turns it into 6. Now, I hope you remember, it's not that long ago we did this. Here we want to get rid of the square root sign, so we would square both sides. That cancels that square root sign out, so you get x plus 4 equals 36. Subtract the 4, and you get x equals 32. On these problems, remember, you have to check it. So let me do a mental check. I'm going to take the 32, I'm going to plug it in. 32 plus 4 is 36. Square root of 36 is 6. 6 times 3 is 18. 18 plus 5 is 23. So it does work. Okay? But you do need to get in the habit of always checking those. Okay, that was a square root equation that we just solved. Now down here, let's do number 8 first. You see, here there is a b term. So if there's a b term, that method of isolating x squared doesn't work because you're going to have this x floating out there someplace. So this is where you have to consider factoring or potentially quadratic formula. And if it doesn't look that bad, I'd like you to try factoring. Here, it's already set equal to 0. Leading coefficient is 1. So I'm going to go with x times x, 5 times 3. This means signs are different. This means the bigger one's negative. Now remember, this is how I kind of check it. This inner term, inner product gives me 3x. This outer one gives me negative 5x. Together, those combine to negative 2x. So it's factored correctly. That's just a check. You don't have to show that. Now, I do have to give the answers. Remember, what's going to make this set of parentheses come out to 0? What's going to make this set come out to 0? And those are actual answers. So this is when you have an x squared term and an x term. You have to consider factoring or maybe even quadratic formula. Now this problem number 7, sometimes people look at this and they want to distribute right away. But remember, this one's already factored for us. That's a good thing. That makes it easy. What's gonna make this first term come out to 0? X would have to be 0. What's gonna make this second term come out to 0? I'm going to do a little side calculation. Move the 8 over, divide, and that comes out to negative 4. If you guys remember the shortcut I taught you before, it's always going to be this number over this number and change the sign. So 8 over 2 is 4, change it from positive to negative. So again, we are considering factoring when we have an x squared term and an x term. But remember, to consider that, or even quadratic formula for that matter, you have to be equal to 0 before you can do that. So here on the next page, on number 9, we would first have to move the 10 over, which will make it negative on the left side. I'm going to try to factor. It looks like it's going to potentially be easy to factor because I'm thinking about 5 and 2. And sorry, that disappeared there. This is going to be plus, that's going to be minus. Make sure you check your factoring. 5x and negative 2x together makes 3x. Don't forget to actually give the answers. And remember, these answers here are where the parabola would cross the x-axis. Okay. Again, at any time, you can try some of these yourself. You don't need me. This is stuff you've done before. You can pause it at any moment. I got to be equal to 0 here. I always want to move things over to the side where the x squared term is positive, though. So I'm going to move things to the left, and I would move it by subtracting. That changes the sign. Aha, you know what I see here? I see a GCF. Always take the GCF out if there is one. Next, I see a perfect square here. So I'm going to try the square root, 6 and 6. Sign's the same. Yep, that works, doesn't it? Negative 6x and negative 6x give you negative 12x. I end up with just one answer there. So, okay, now here we have a cubic, right? We have an x to the third. So you want to move everything to that side where you have the highest power. And of course, you have a GCF here. This GCF is just x, but it's very important that you take that out. Now here, I will tell you, this one's potentially a little bit harder to factor. You could maybe use quadratic formula here, but it is factorable. And while it's harder than some of the other ones we've done, it's still not that bad because these n numbers, 3 and 7, are both prime. So if I say 3x and x, my only option to make a 7 is 7 and 1. It's just a matter of where I put it. And if I put it there, see that makes 7x, that makes 3x. Together that makes 10x. Now here I'm going to get 3 answers. Remember, this is 7 over 3, make it negative. And that's 0. Whenever you have an x in the front, you are going to have an answer of, one of your answers is going to be 0. Okay? So we had 3 answers there because that was actually a cubic equation initially. And I'm just cranking along here. I would add 5, turns that into negative 3. Again, if you were doing this on your own, without any guidance at all, you would maybe go straight to quadratic formula here, which wouldn't be a wrong thing to do. Again, quadratic formula always works. Turns out this one there does factor. There is no GCF, but these things are prime, so it's not too bad. And if I do 3 and 1, you see this makes 15 and 1. 15 and 1 can make 14, as long as I get the signs right. Again, I'm going somewhat fast here, but remember, we're going to do a live lesson on Tuesday, April 28th at 1:30, talking through all this stuff. Okay, now we're going to get into some word problems. Don't freak out about that. We've done this many times. Rectangle problems. Which side do you not know anything about here? It says the length of a rectangle is 3 more than twice the width. Looks like I don't know anything about the width, so I'm going to call that W. Now it says the length is what? 3 more than twice the width. 3 more means 3 plus, and then twice the width would be that. So I'm going to have an equation now. Remember, it doesn't give me perimeter, it gives me area. Area is length times width. So W times, I'll write it as 2W plus 3, but that's just length times width, has to be 65. Now I'm going to do a few things here in this next step. I'm going to distribute, but I'm also going to move the 65 over at the same time by subtracting. And now it actually does factor. This one's a little bit harder to factor because that 65 is kind of big, and a lot of times people don't always recognize the factor pair of 65. It is going to be 13 and 5, but I'll be the first to acknowledge that this is a harder one. You would maybe do this on, quadratic formula if you had to. But watch this. This does make 10, and this makes 13. 10 and 13 can combine to 3. Signs are different. Bigger product is positive, so this is the bigger product of 13. So I get two answers. I get W is 5. I get W is negative 13 over 2. But remember, the width of a rectangle cannot be negative. So that answer gets crossed off. Doesn't make any sense. Find the dimensions of the rectangle. We got a width of 5. And if you plug the 5 in here, 2 times 5 is 10. 10 plus 3 is 13. You get a length of 13. So that is your final answer. All right. Solve for x if the triangle's area, there should be a little apostrophe here, right? Is 80. How do you find the area of a triangle? I'm hoping that you remember that the area is going to be base times height over 2. Okay. And actually, they told us the area was 80, so let's plug that in there. And now we just have to solve that. Now, one thing you can do here is you can solve this a bunch of ways, right? X times 4x is 4x squared, but 4x squared over 2 is 2x squared. Divide by 2, and you get 40 equals x squared. Okay, now that's not going to be a nice perfect square. If we take the square root of that, we do get x equals 6.32. Now, normally when we solve using the square root method here, that's what we did. We used the square root method. Notice how we only had an x squared term. Normally we would write plus or minus. But remember, can't be negative because the side of the triangle can't be negative. So you only give the positive answer here. All right. Excuse me, just got a little bit more to do here. I got a word problem, everyone's favorite. Height of, we did these before too, remember that? Height of a drop ball can be described by the equation h equals negative 16t squared plus 400. H is the height of the ball after t seconds. So it's dropped. If you guys remember, this 400, that's the starting height. So this would be on the top of a very tall building. And at any particular time, you could figure out how high the ball is. So at 0 seconds, if you plug 0 in for t, this becomes 0, and the height of the ball is 400 because you haven't dropped it yet. Find the height of the ball after 3 seconds. We are just going to plug 3 in for t. Now remember, you got to square the 3 first, so that becomes a 9. And now you get negative 16 times 9, add 400, you get 256 feet. So after 3 seconds, the ball is still pretty high. Okay. Now, this is where you got to be thinking a little bit. When will the ball be 200 feet above the ground? What are you given here? Are you given T or are you given H? Clearly you're given H. So we're going to replace H with 200, and we are going to solve for T. But remember, this equation here, there's just a T squared. There is no T. So we can solve this using the square root method. So I can just go ahead and isolate T squared by subtracting 400. And I get negative 200 equals negative 16t squared. I'm going to divide both sides by negative 16. I get 12.5 equals t squared. And then, of course, I would take the square root of that, and I'm going to get 3.54 on my calculator. Now, I'm also going to get negative 3.54. But again, remember, t is time. We can't go back in time. So we have to discard the negative answer there. It doesn't make any sense. All right? I'm hoping that this stuff rings a bell here. How long does it take for the ball to reach the ground? Remember, when the ball reaches the ground, the height is then 0. So we're plugging 0 in for h. And again, just like we did in part B, there is no b term. It's just a t squared. So we are going to isolate t squared. Divide both sides by negative 16. You get 25 equals t squared. That's a nice perfect square. We actually take the square root of both sides and we get t equals 5 or t equals negative 5. But again, we are going to keep this answer because we're talking about seconds and we can't go back in time. So I hope that all rings a bell. Remember, somewhat quick in places there, folks. We're going to do the live lesson at 1:30 so you can ask questions. 1:30 on Tuesday, April 28th. See you then.